So today we're going to talk about medians. This is the last thing we're doing before our quiz on Friday. A median of a triangle is a segment from the vertex to the midpoint of the opposite side. Three medians of a triangle are concurrent. That means they meet up at the same point. This point of concurrency inside the triangle is called a centroid. So the centroid of a triangle is 2/3 the distance from each vertex to the midpoint of the opposite side. The medians of triangle ABC meet at a point P. So AP is twice as long as PE. BP is twice as long as PF. And CP is twice as long as PD. So for my first example, it tells me in triangle RFT, point Q is the centroid, and SQ equals 8. Find QW and SW. So I know that because it's a centroid, SQ should be twice as long as QW. And I also know from the sentence that SQ equals 8, so I can replace that with 8. Then I want to go ahead and divide both sides by 2. I get QW equals 4. Okay. And then finally it wants me to find the length of SW. I can use the segment addition postulate here because I know that SQ added to QW should give me the entire length of SW. I know that SQ was 8 and QW is 4. So I get SW is 12. Okay, my next one says, if D is the centroid of triangle PQR, PA is 17, BD is 9, DQ is 14. I need to find the length of each measure. So I have AR is the first one I'm looking for. Centroids are created by the midpoints of the sides, so I know that these two halves have to be the same. So they're both going to be 17. Then PR is the entire length across, so I want to add the two 17s together. That gets me 34. Next, I'm looking for DR. I know that DR is going to be twice as long as DB, which I have is 9, so I can go ahead and replace that. BR equals 18. BR is adding all the way across, so if the top one's 9 and the second one is 18, this gets us 27. The next one it wants me to find is AD, so I know that DQ is twice as long as AD. DQ is the one I know, so I can replace that with 14. And I want to go ahead and divide both sides by 2. So I get 7 for 80. And then it wants me to find the length of AQ. That's adding those two segments together. So 7 plus 14 gets me 21. Okay, so on the back side, we're just going over centers of triangles that we've covered in this chapter. So the first one I have is my circumcenter. This is created by perpendicular bisectors. And the circumcenter is equidistant from each of the vertices of the triangle. So AM, BM, and CM are all going to be the same length. Okay, for my in-center, this is created by angle bisectors. And the in-center is equidistant from the sides of a triangle. So here I'm going to have XM, YM, and ZM are all congruent. Then I have my centroid. This is created by medians. This is the one we talked about today. So a centroid is created by a vertex connected to the midpoint of the opposite sides. So on this one, instead of highlighting, I'm going to note that BM is twice as long as MZ. So the longer part is 2 times as long as the shorter part. And then finally we have our orthocenter. This is a word that might appear on your homework or your quiz. This one is created by altitudes. What an altitude is it is perpendicular to a side and it goes through the vertex. So an orthocenter is created by a vertex connected to the opposite side so that it's perpendicular to its side.